So today we're going to learn about properties. Commutative property of addition and multiplication. It basically means the order of the numbers does not affect the sum or the product. Can anybody in here give me an example of the commutative property? Let's write that first one down. And one example of the commutative property would be like, whoa, computer. So basically, commutative property says order doesn't matter. We could also do it with addition. It doesn't really make a difference. 3 plus 2 is the same thing as 2 plus 3. So one person might have 3 times 2 written on their paper. I might have 2 times 3 written on the board. Doesn't make a difference. So associative property. Basically, associative property applies to addition and multiplication. Says the way the numbers are paired does not affect the sum or the product. Let's see if we could think up an example on our own. Here's one for addition. Here's one for addition. So how about this? 3, oh, computer. So associative property, doesn't matter how they're paired up, it's not going to make a difference. Associative property typically always has parentheses, and so that's something to keep in your mind when you're looking for it or when you're trying to use it. Yeah, so here we go, 2 examples for associative. All we're doing is just changing the groupings on the items using parentheses. Distributive property, this is everybody's favorite. People love this one. What's distributive property? Can I get one example of it? So that's distributive property. Yeah, we thought up a great example. 5 times 3 plus 2 in parentheses is the same thing as 5 times 3 plus 5 times 2. Doesn't always have to be numbers. Could be variables on the inside also as well. Additive identity. You'll have to remember this one. So what is the additive identity? It's a person, a thing, an object. It's a particular number, and it never, ever, ever changes. Who is the additive identity? 0. The additive identity is 0. 0. Because anytime you add or subtract 0 to a number, you always get the number. Somebody give me their favorite number. 9? Cool. 9 plus 0 is 9. I'll give you my favorite number, 7. 7 minus 0 is 7. The additive inverse. This one's easy. The additive inverse is sometimes always called the opposite of a number. My favorite number is, once again, 7. What's the additive inverse of 7? Yeah, it's that easy. So in any event, anytime you have a number, if you add its opposite or its additive inverse, you always get 0. That property is particularly useful when you are trying to move things back and forth on an equation and try and solve for a variable. The multiplicative identity. Who's the multiplicative identity? Yeah, the multiplicative identity is 1. This property is most useful when you are dealing with fractions. Because if you multiply top and bottom by the same thing, it doesn't change the item, but it will make it look different. Like the denominators suddenly become common and you can add or subtract them. All right, so any number multiplied by 1 leaves the number unchanged. Somebody else give me their favorite number. Maybe their sports number. 17? 17 times 1 is just 17. Very nice. How about the multiplicative inverse? This is also useful when you are trying to solve fractions, right? The multiplicative inverse, or reciprocal. What's the word reciprocal mean? Shoot, Jermel. Yeah. Perfect. Give me a fraction, Jermel. Sure. What is the multiplicative inverse of a half? See, close. No. Yes, just 2 over 1. It's just 2 over 1. Yep, there you go. The 0 property. The 0 property. So it turns out anytime you multiply a number by 0, what do you get? Piece of cake. Let's do, oh, I don't know. What's today's date? Today's the 12th. 12 times 0 is just straight up 0. The symmetric property. Values on both sides of an equal side are the same. This one's a little weird, so I'm going to do this one with you. The symmetric property always looks like this. B plus A is the same thing as A plus B. And I know it kind of looks like the commutative property. Symmetric property of an equality. Values on both sides of an equal side are the same. The reflexive property is basically like you looking at yourself in the mirror. It says that A is always equal to A. It kind of happens when you get down at the end of an equation. Suppose you have 17 equal to 17. The reason you can write that down is because of this one. And the transitive property. The transitive property, I think, always is like the train property. Does anybody remember this from geometry? Maybe perhaps geometry honors? Could somebody give me an example of what, like, the transitive property? So there you go. There's the transitive. A equals C. C equals B. You can make that bridge, make that jump, make that logical conclusion that A equals B. And that's pretty much all the properties that you're going to need to know. If you can work within those properties, you're going to be golden. Use. So what do you guys think? What do you guys think? What do we think? Here, we're going to run through some properties. We're going to practice a little bit. What's this looking like? The first thing I'm seeing is parentheses. Parentheses only normally go with two of those properties, either the associative or the distributive. What are we thinking this one is and why? Emily? No? Oh, Emily. Good. You're amazing, Emily. Yeah, it's C. Totally. All right, let's try the next one. How about something like that? What are we thinking? Shoot. Definitely distributive property. Very nice. Let's keep going. How about this guy? Shoot. I'm thinking it's the multiplicative identity, because anything times 1 is itself. Carly? Yeah, wait, which one? The additive. Yeah. The additive inverse. Very nice. Yeah, if you don't want to say it out loud, we can just say the letter. Some of these guys have some weird names. All right. Uh-oh. What about this one? What about this one? Now, this one's a little weird. We do see some parentheses, but look really carefully about what's going on. Anna. Yeah, we are just changing the order of the events inside those parentheses, and there's addition, commutative property of addition. Very nice. I am thinking this is what? Shoot. I think it is. I'm thinking it might be J. Because anything times 0 is just straight up 0. What about that one? It is, yeah, looking at itself in the mirror. Looking at itself in the mirror, it's the reflexive. No. Symmetric. Let's think for a minute. I always get confused about these. We're going to go with this one as the symmetric. How about this? What do you think, Olda? It is the multiplicative inverse. Yeah. And this one? Yeah. Multiplicative property. No, hold on a second. I don't know if it's the property of 0. Look real closely. Carly, if this wasn't here right there, I would say totally yes. But we are moving stuff around inside those parentheses. Shoot. Yeah, commutative property of addition. Flipping stuff around right there. You could say a whole bunch of things for this one. I think there's different stuff. What do you guys think? Shoot. Yeah, commutative property of addition. You might also be able to say what else? Shoot. Yeah, I would say, let's see, is it symmetric or is it reflexive? I need to go look back at my notes. Yep, you could have also said the symmetric. How about this? Shoot. Yeah, additive identity. Anything plus 0 is itself. How about this guy? A plus B, then B plus A is the same thing. Shoot. I don't, you know, if we had an extra, like, bridge type thing. Anna? Yeah. Yeah. I might say K. I might say K. Yep. We can flip stuff around. How about this one? What is going on here? Stuff in parentheses. Shoot. You know, I would totally say distribution. The only problem is that whenever you see the distribution, the parentheses release themselves. I would also totally say that, except that it doesn't match perfectly. We're seeing stuff rotate. We're seeing the order of things switched around. So which one means the order of stuff? Very nice. Commutative. How about this? Hold on. Whoa. John? John, buddy, what do you think about this one? Yeah, this one's distribution. E. And this one? Reflexive. Very nice. So we're getting the hang of it. We're getting the hang of it. And this one? I don't know about that. Maybe. And I could see kind of how you would say it. But what's the property? The what? Yeah, anything plus 0 is always itself. Additive identity. A, B, C, D, E, F. How about this one? Anna. Yeah. Multiplicative property of 0, J. How about this one? Uh-oh. Let's take a look. Let's take a look. We have parentheses. We have what's going on? Jamie. Which one is it? Very nice. Yeah, D. Very nice. Oh, man. We're getting towards the end. So this one's a peculiar looking thing. Shoot. Very nice. Yeah, transitive property, because we're making that jump from 2A equaling B and B equaling 3C to 2A equaling 3C. And finally, I think, last one on this sheet. Let's go with somebody new. Yeah, multiplicative identity. Anything times 1 is just itself. Let's flip over that page. Okay. Let's take care of some properties, some ideas that you might necessarily not know about. Are the integers closed for division? Why or why not? Does anybody know what this idea of closure means? It has to do with like sets and whatnot. Yeah, so the integers are all the whole numbers, positive and negative plus 0. And if you took like 2 of them, let's say, for example, 10 and 3, 10 divided by 3 is, I think, 3 1/3. Is that true? Right? And that's not an integer. What kind of number is 3 1/3? What kind of number is this funny looking thing with that line drawn in between? Shoot. It's called a fraction, and the really fancy name for a fraction that scares people off is what? It starts with an R. Yeah, it's a rational number, and rational numbers are, rational numbers can be integers, but not all integers are rational numbers. So the next one, are the whole numbers closed for multiplication? The whole numbers. By the whole numbers, I mean 0 and anything forward from 0. You can't have no negative numbers. So if you took 0 and you took every number, every whole number there afterwards, no fractions, and you multiplied them, would you only get whole numbers, or would you get other things like fractions, like negative numbers? What do you think? Yeah, these guys are closed. Yes, because, and you could just give an example. 0 times 7 is 0, and 7 times 2 is 14, right? And sometimes when we ask you to prove out questions, instead of writing down every single case that's possible, the best way to answer a question is just to find that one case that disproves it, and then let your statement then just be quiet and let it go. Like on our previous problem, right? We found one number, so these guys are, I forgot to write it down, these guys are not closed because they let fractions into the party. And so this one is, yes, it's closed. I should be writing in whole sentences. Forgive me. How about this one? Are the natural numbers? Do you guys know what the natural numbers are? Anybody here have a little brother or sister, real small, like very infantile? And anybody in here interested in becoming a really young, like elementary preschool teacher? Anybody in here seen a baby before? Okay, all right. So when you, hopefully somebody in here, people in here are gonna hopefully one day grow up to be mothers, yeah? When you have a baby, you can tell if your baby, or even you yourself, if you think back about it, how you learned to count was on your what? Your fingers, and you'll see like you can mess with little babies, right? You'll put some Cheerios out, and you'll put one out, and you'll go like this. And the baby hopefully will like smile, think it's funny, and will try and hold up its like hand, you know, probably to try and grab it, but eventually they'll realize that they could count stuff on their hands. And this is the most natural way to count. Does anybody know the trick for multiplying by 9s on their hands? Oh, good. Does anybody not know the trick for multiplying by 9s on their hands? Give me 9 times any normal number. Don't pick like 7, please. 4. So 9 times 4. 1, 2, 3, 4. 9 times 4 is 36. So that's how, you'll see a lot of people multiply by that. You can't do that with every number, but with 9s it works. Okay, are the natural numbers closed for subtraction? What do you guys think? The natural numbers. Do you only get natural numbers when you subtract them? No, give me the one case that might disprove it. Just give me the numbers. Shoot. Yeah. Yeah. 1 minus 4 is -3. And if you tried to explain that to a very small child, that you can have actually less than nothing, they would be like, no. You know what I mean? It doesn't make sense to them because they can't count that on their hands. That is not a natural number. Not closed. Not closed. Very